Read this. Any explanation needed, I will be happy to do that. Any explanation needed. Photoelectric effect is one of the chapters I've seen which is really very, very scoring. If you understand things, they are really piece of cake. Once the confusion starts, then it is really a hodgepodge in the brain. This is really a very scoring because you can never go wrong with this. Other things, there are complicated formula, scenarios and all that. This is really very easy. Yeah, we will see that, Abhiraj. Any question up to whatever I have explained so far. I cannot jump few slides. I will cover that. That's a good question. We'll see that. Okay, Abhiraj, any question based on what we studied so far? Okay, let's see. Okay. So threshold frequency and the wavelength. So let's try to understand this. Let's say the same piece of metal, and there was an electron here which needed 3 electron volts. There was an electron here, 4 electron volts. More electron here needs 5 electron volts, right? So the work function is 3 electron volts. So I'm claiming that the photon should have at least this energy. At least doesn't mean exactly this much. You can give more energy, that's fine. I need at least 3 electron volts. Give me more, I'm fine, right? So energy is equal to h times the frequency, right? So now if I calculate a photon, I find a photon with exactly this much of energy. This frequency is called the threshold frequency. So the threshold frequency would be the work function divided by the Planck's constant. So any light with this frequency or more is good. This is the minimum frequency of a light that is going to make photo emission. So in our case earlier, if blue light is emitting the electrons, ultraviolet will happily do that. Radio waves cannot do that, or not even green light can do that, right? So this is the minimum frequency, threshold frequency, and corresponding wavelength, which is speed of light by frequency, will be c divided by phi times hc by phi. That is the threshold wavelength now. Now the value of hc, everybody, I told you to memorize, is 12,400 electron volt angstrom. Read this. Any explanation needed, I'll do that. Now this is the part, by the way, that was puzzling everybody. This was puzzling everybody before Einstein came in and gave the dual nature. Because with waves, this doesn't make sense. If you think light is a wave, this statement, this observation doesn't make sense, and we'll study that why. But as soon as you say particle, everything starts making sense. Behavior as a particle. Yeah, so please see this. So memorize the value hc. It is going to save your time in competitive exam. 12,400 electron volts. Otherwise, you will be busy calculating all this. That's what I'm saying. When you keep doing this, and then you do this, right? This is going to take your time. You memorize few things. I really want everybody to memorize. Not everything has to be memorized. Few things definitely have to be. Chalo, let's move on if there are no questions there. So work function jitna bhi tha. So in the first case, the light ray has the h times frequency. The energy of photon is less than work function. No electron is emitted. In the second scenario, there is enough energy. Electrons are emitted. You can see these are emitted here. Variation with intensity. Does everybody understand how would the intensity be? Let me ask a question here based on common sense or intuition. Or maybe not. More is more intensity, more current means more electrons will be emitted? Yes or no? So what we are saying is if the intensity of light is more electron emitted or not? By intuition, you tell. Maybe, may not be. I don't know. Maybe, may not be. Okay. So there are few students who actually are saying false, but yeah, it is true actually. So let's see why. We are just doing by common sense. We are not trying to do any formula as of now. No heavy formula. So electrons, 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 right? So what is intensity of light? You see, in the case of wave nature, intensity of light is this. This was a wave. This is more intense wave, right? Isn't that intensity of light? More the amplitude, more the intensity. Does everybody understand that part? In the wave world, more the intensity just means more amplitude, right? And that means more energy. More intensity means more energy. But in the particle world, more intensity doesn't mean that. So this is photons falling on this, more intensity. So let's write it down. In the wave world, you have to really understand this. More intensity means, please note it down. This is a very important point that will make you understand why wave theory failed to explain all this. More intensity means more amplitude and energy. Okay, that is what it means. Now in the particle world, let's say in photon world, more intensity means more number of photons. So if there are a million photons falling, 2 million photons is more intensity. But same energy. Each photon still has the same energy. This is a very big difference between wave and photon. So when you look at the wave theory, more intensity means more energy, but in photon we are saying more the intensity, energy doesn't change. Each photon still has h times frequency because the color of light is not changing. But each photon has be having same energy doesn't matter, more photons are falling on it. Now if more photons are falling on it, doesn't that mean more electrons will be emitted? Because all those photons were not emitting electrons, but if you're throwing more photons, more chances of electrons absorbing them and more the current here, more electrons will go out. Right? So this is the thing that we're trying to say. If intensity goes up, number of electrons released goes up. That means the current goes up. This is after all electric current, right? Flow of electrons is current. So the current goes up, photo current goes up. क्लियर है सबको? सबको क्लियर है? ठीक है? So we will make a kind of setup here and let's see how we can study all this. So let's say we have I'm making some rough kind of sketch here, rough and ugly maybe. So let's say this is a photosensitive material. This is a plate. Photosensitive plate. ठीक है? It can really release electrons. Now on the other side of the world we have some plate and I'm connecting this, and maybe I'll connect a galvanometer here to measure all this current that goes in. ठीक है ना? Electrons are released. Please remember, understand this carefully. Electrons are released. Electrons might reach here. If electrons reach here, they are flowing through this. Current is flowing. No battery, no power, no solar power, nothing. And this is photoelectric effect. Now, obviously, we're assuming this is vacuum here. ठीक है? This is photoelectric effect. Now let's see what happens if more intense light comes in. So there were photons that are coming in here, falling on the plate. But if I increase the number of photons, oh, the current shoot up. So what would happen then? So intensity of light versus, oh, I means intensity of light. Let's say current here. No intensity, no current, right? There is certain intensity needed. Current is still zero. You should have this kind of graph. More the intensity, more the current. Clear है सबको? Clear है? ठीक है. Now, what would be the effect of let's see the slides actually. Slides are really good here. Yeah, this was the thing I was trying to make. This was the thing, right? So what we have done is in addition to the measuring device, which is galvanometer or ammeter, we also put a battery here. So let's actually do that. इसन्होंने उल्टा बनाया, मैंने उधर से बनाया था, doesn't really matter. So let's say I put some battery here and see how that will help me now. So current was still in there. I don't need a battery, honestly. I don't need a battery. But battery will make it better. Let's say this is battery, this is positive and this is negative. अब positive negative से क्या होगा कि this was positive here, है ना? Let's slow down a little and make more room here. Electrons were emitted, no doubt. What was happening so far was some electrons were reaching here, some would stop here, some would stop here because of all the air resistance, right? Because not everybody has the same energy. Remember, we had this. There was electron here, there was electron here, there was electron here. So this one when released will have maximum kinetic energy. How much kinetic energy? See, HF was the energy I was giving it, was equal to used up by work function plus the kinetic energy. So kinetic energy is equal to HF minus the work function, but this is the maximum kinetic energy is key, right? Under wale electrons will have less kinetic energy. So they might stop here. So when I connect this battery, maybe this will be pulled because there is positive potential here. I get enthusiastic and say, okay, let me put another battery here because then the potential positive is more here. So maybe this will also be pulled. Then I get overly enthusiastic. I put more battery, more pulled. But then what would happen is if a million were released here, all million are pulled here. There is no more point in putting more battery anyways. ठीक है ना? I'm pulling all the electrons that are possible. I keep doing more potential, it doesn't help. And that is why you will see this kind of behavior. This potential, this battery's potential versus the current here. Even without the potential, I had some current. So I got to start here. As I increase the potential of the battery, this will increase, but up to a saturation value. After that, there is no point. You keep increasing the potential, you don't get any more current because all the released electrons are already pulled in. I'm going to pause here for everybody to just digest all this information. This was a little heavy, I'm telling you. So slow down. Everybody, Sai Kumar, Abhiraj, anybody who has a question, Ninad, everybody, please work on this. Shreya Bhatt, you got to speak in the class, please. Anybody, please. No questions, no doubts. So let me take individual names because this is a very scoring topic. Shreya Hegde, Shivangi, Sai Kumar, Rukaiya, Rupa, Ninad, Manju, Monisha, Grishma, Ganit, Atri, Arvind, and Abhiraj. Has everybody understood this? Has everybody got it? Okay, if you got it, then it's good. Then that is excellent. So this was the setup here, and let's see what happens as a graph. So variation of current with intensity, right? So now we are seeing what happens with intensity. With intensity, obviously the current goes up. We already saw the reason of that, and also the effect of potential difference. Yeah, so I'll show you the graph here. Where is the graph? Here a graph. Don't look at the left hand side, please. You'll get confused. We have not done that. We will do it now. So you start with the zero potential. Even with zero potential, current was there. So you don't start from origin. That is why you don't start from origin. You start here. And then after some time, there is a saturation reached. ठीक है, clear है सबको? ठीक है. So now let's see the other side of the world. As in you flip the polarity of the battery. We'll do it here. So ये plate थी, ये photo current. This is the photo plate. And then this was the one which was capturing all this. This is a galvanometer or ammeter. अब मैं उल्टी battery लगा देता हूँ. Negative here, positive here. So what would happen with that is this is negative. The electrons which were with full enthusiasm going to the black plate, they would be repelled because this is negative. ठीक है ना? But then see, different electrons had different kinetic energies. The weakest ones will be not reaching there at this point of time. Then I say, okay, I'll increase the battery here to more negative. So more energetic ones will not be able to reach there. I keep doing that. The most energetic are stopped now. And this potential, when the most energetic are stopped, as in the current goes to zero, is called the stopping potential. The stopping potential. So how do I calculate it? So look at this. I had this expression. So we will start from beginning. Everybody, please see this. I keep doing it 5, 6, 7, 8, 9 times so that everybody understands this. H times frequency is the photon's energy that is falling, that was used up to release the photon plus give kinetic energy. And this kinetic energy, you're talking about the surface molecules. So that is the maximum kinetic energy of any electron. So kinetic energy maximum is equal to HF minus phi. ठीक है, clear so far? I have to stop this particular electron. So in order to stop it, I have to provide E times V naught, which is the stopping potential. Charge times potential is energy. So all this is energy, right? It all makes sense. So the stopping potential is going to be H by E F plus phi. Actually, usually it's written as phi naught. So phi naught by E. So this is the stopping potential. ठीक है? Does everybody understand stopping potential? Is this clear? Sai Kumar says yes. If it is confusing, I'll do it one more time. That's what I'm saying. तो stopping potential की बहुत अच्छी वो आ गई हमारे पास. Yeah, we'll do that later. But think about it. What does the stopping potential depend on? Let's go one by one. This is a property of material, right? Phi naught is a property of material. This is a property of electron. These cannot change. H is a constant. This is a property of this. So stopping potential only depends on the frequency and nothing else but frequency. It only depends on frequency, because more the frequency, more the kinetic energy, more you have to apply for it. But what if I apply more intensity of light? So what you will see is if intensity of light is increased, more current, so current का graph ऐसा हो जाएगा यहाँ पे. But if you go back, it is still going to do here. If intensity is reduced, the current will increase here, so less current, ठीक है? Less current, less intensity. And this is going to still go back here, because stopping potential does not depend on intensity, it only depends on the frequency of light. Assuming these three lights are same frequency, different intensities, this is the behavior. You really have to understand, don't try to memorize any of this here. See, I'm giving 1 minute to everybody. Okay, so let's move on. Nobody is asking question. So dependency of photocurrent on frequency and the conclusion there. तो देखो, अच्छा वो तो हमने इंटेंसिटी करी. अगर फ्रीक्वेंसी इंक्रीज करते हैं, saturation current will not increase, because see what happens if you increase the frequency. Uh, let's see, photoelectric intensity. So please understand that the current only depends on the intensity, doesn't it? More the photons, more the emission. It has nothing to do with the color of the light here. As long as you can release electrons with a photon, then you don't care about the current being dependent on the frequency of light. Yeah. So you're right. So this graph, as Ninad is saying, is the same intensity but different frequency. So because there is same intensity, there is the same saturation current. Intensity, let me write, intensity is same. Now, on the other side of the world, stopping potential only depends on frequency. Because you're changing the color of the light, stopping potential will change. Less frequency, more frequency, more frequency, right? More frequency needs more stopping potential because it has more energy per photon, and that energy is transferred to electron. Now, these are the direct questions that come in exam, and if you try to memorize, things will go wrong because they will twist it. थोड़ा सा variation हो जाएगा इधर उधर. So try to understand what's going on here, please. Anybody who did not understand any of this, please let me know. देखो intensity is a current अगर देखें intensity versus current. Look at this tiny graph first. More the intensity, more the current. Double the intensity, double the current, because double the number of photons, double the number of electrons will come out. 1/10 number of photons, 1/10 electrons come out. So this is directly proportional. Obviously, it's a straight line. Now this one is intensities are different. Take a same frequency. So this is frequency. Frequency is constant. So because frequency is constant, you can see the stopping potential is constant. You got to understand that part. But because intensities are different, saturation currents are different. Intensity defines the saturation current, frequency defines the stopping potential. Now, on the other side, the intensity is constant, see, and that is why the saturation current is same. But frequencies are different, so that effect can be seen here. That effect can be seen here. Okay, so I'm going to personally ask everybody. I cannot believe that nobody has any questions here. Abhiraj, Arvind, Atri, Ganit, Grishma, Monisha, Nina, Rukaiya, Sai Kumar, Shivangi, and Shreya Hegde. Any comments, any questions? Any comments or any questions, please? First is for Nina says first is for different intensity, हाँ ठीक है, and second same yeah, and the same frequency, yeah. First graph is same frequency, different intensity. Same frequency means stopping potential is same. This is the one and only one equation that you have to master. Seriously, this h times frequency is equal to work function plus kinetic energy. But work function itself can be written as, see, work function is written as hf naught, right? The cutoff potential frequency plus kinetic energy. And this is the maximum. These are for the surface molecules, surface electrons, sorry. So kinetic energy maximum is h f minus f naught. Okay. Now you can also say this is equal to E times the stopping potential. So stopping potential is h by E frequency minus h by E frequency naught. Stopping potential purely depends on frequency. And this is, isn't this equation y is equal to mx plus c? And that is what the graph is going to look like literally. So y is the stopping potential versus the frequency. It should have a y-intercept of negative here and a slope of h by e. Okay. So slope is always constant because h is a Planck's constant. E is also electron charge, that is a constant. So doesn't matter what material you take, what color of light you take, doesn't really matter. Slope of the line will be same. What will matter with the materials here is this, because f naught is defined for a material. So let's say we take another material, the graph is going to look like this. The intercept will be different, but look at the slope. It's exactly plain line. So these are the graphs for different materials. So as you increase frequency, voltage increases, but the slope of the graph is a universal constant, you can say. Anybody who did not understand this? EV is equal to K, समझाओ, देखो समझो ठीक से. EV क्या होता है? Electron volts, right? So what is potential? Potential is work done per unit charge. Do you understand this part, Arvind? Do you understand this? You understand this, ठीक है? तो वर्क क्या हो गया? Potential into charge, ठीक है ना, joules is voltage multiplied by coulomb. इलेक्ट्रॉन वोल्ट इज अ यूनिट ऑफ एनर्जी. तो हम क्या कहते हैं कि हमारे पास दो प्लेट्स हैं and there is a potential difference of 1 volts here. Maybe this is 0 volts and this is 1 volts. Let's say plus 1 volts. We take one electron and just release it. वो क्या होगा? It will be attracted towards this plate, wouldn't it? Attract हो जाएगा ना? It will be attracted there. So there is a force there. There is a displacement here. The amount of work done just now is E times the potential difference. That is the amount of work done. When an electron is accelerated through a potential difference of 1, that is called 1 electron volts. अब इसमें क्या होगा? When it is accelerated, there is work done here. That work is converted into its kinetic energy. So far, is it clear, Arvind? I'm not done, but is this clear so far? So all that work done by the plate is converted to electron. Now we are going the opposite way. What we are saying is this is a photosensitive material, photon आया, and it released an electron, and remember it had some kinetic energy. Already it had some kinetic energy. Now what we are saying is we are going to give negative charge here. इधर हमने positive दिया था, तो we were accelerating. Here you are deaccelerating that. So my purpose of life right now is that electron should almost stop there. Just before reaching there, it stops. So just before reaching here, there was a work done which was E times the potential of this plate, which I don't know how much that was. And that work done should be equal to the negative of kinetic energy, because remember work energy theorem, the net work done is change in kinetic energy. Change in kinetic energy is negative Ke, and the work done here is negative because the force is in this direction, the displacement is in this direction. So this should be equal to the kinetic energy max. And this is called the stopping potential. You can provide more potential, fine. What I was calculating, it just पहुंच गया and then it stops. If you provide more, maybe it will stop here, maybe it will stop here. So this is the stopping potential. That's the minimum potential you need to stop the electrons with the highest energy there. कम energy वाले वैसे रुक जाएंगे. Highest energy वाला just यहाँ करो तक. With more potential, can they move back? So Arvind Thakur, keep asking these questions. They really help. With more potential, they will definitely go back because they'll be repelled. Acceleration क्या होता है यार? तुम acceleration देखो ना. So there is a body and body has a velocity of 10 meters per second here. ठीक है? I apply a deceleration of 5 meters per second square. और वो चल रहा है, रुक नहीं रहा. ठीक है? तो after traveling some time, maybe after 1 second, the speed हो जाएगी उसकी 5 meter per second. ठीक है? After 2 seconds, the speed will be 0 meters per second. After 3 seconds, उसकी speed हो जाएगी 5 meter per second. And then it keeps increasing in this direction. It goes on to 10 meters per second here. It keeps on. होता तो है. देखो, look at this. This watch goes up. It has a velocity of going up. Acceleration is always downwards. So the body goes up, stops. Acceleration doesn't stop. So then it starts going backwards.